Far East University, MOOCs, massive open online courses, 3D printing DIY. Hello, I'm Zhan Guo-zhen of Far East University from the Department of Innovative Product Design and Entrepreneurship Management. So today's lesson is to introduce the application and development of 3D printing. Some practical operations will also be introduced. It will show you how to set some parameters. There is also some related knowledge, such as entering and loading. Basically, 3D printing can be traced back to 1981. Later, we will introduce the history of 3D printing. In fact, 3D printing is widely used now because now many people are advocating the so-called Industrial Revolution 4.0. In fact, it is going to allow all manufacturers to introduce machines and automated processes. So basically, 3D printing is applied in various fields, more and more. So today, what I mainly introduce to you is, in addition to some basic knowledge and common sense, I will also give you a brief introduction to the future development. I will also tell you what kind of material applications does 3D printing have for the household, and other models, including molding methods. There are some differences. I will introduce them to you later. So what exactly is 3D printing? Actually, 3D printing is very simple. It is to build a mold in the computer. Like a 3D model, it may be like SolidWorks or software, such as Pro-E. In fact, we often make 3D modeling, aside from the two mentioned. What I will introduce to you today is Rhino and the new Autodesk Software Fusion 360, and software like Google SketchUp. Show you some 3D modeling. At the same time, I'd like to explain something. What is the difference between these software? 3D printing is the result of 3D modeling. First, it is turned into codes, next transferred to the machine by coding, and then piled up by printing them layer by layer. This is 3D printing. The main 3D printing process can be divided into three parts. At first, of course, is 3D modeling. As just mentioned, if there is no basic modeling, there will be no advanced output. After the modeling is completed, the slicing software will be used. The slicing software is mainly used to translate our current models. The finished mold divides them layer by layer to enable the computer to code, so it can be introduced to our current 3D printer. Finally, the finished product is a 3D product. Of course, the 3D printing products are also limited by materials, or some of its own machine features will have different effects that may require some subsequent processing and back-end processing. In fact, the rear-end processing of each machine, for example, the construction method or the time required, will be different. Let me mention again the development history of 3D printing. The earliest development of 3D printing was in 1981. It was invented by Kodama Hideo of Nagoya Municipal Industrial Research Institute. What he invented at that time was the so-called light curing machine. It is now called SLA. But at that time, it was for research purposes. He did not actually introduce it into mass production. Then, in 1984, there was a man named Chuck Hull from 3D Systems Company. He used SLA technology to be applied in business. Then, the major contribution is, most 3D printing now includes a file called STL. It was originally designed by Chuck Hull. So now what we use is SLT. In the beginning, it was made from the so-called SLA light curing machine. In fact, the FDM we use now, it is a machine of molten laminated plate type in the late 1980s. He has been doing some research and development since the previous launch. It can be carried out in the mass production stage. In terms of the household wares now, it showed up after 1990. It was mainly used in the 1980s. The so-called FDM appears in its later stage. Just because it has been mentioned, some complicated terms like SLA and FDM are also mentioned. Then I will explain it to you in detail. What is FDM or SLA? First of all, let's talk about FDM, which we will focus on today. The so-called FDM is a molten stratification. It seems that the material is melted and then slowly stacked layer by layer. This is the so-called FDM machine. Compared with the SLA, the FDM machine we will introduce later. It's much less expensive. From the raw materials to the machines, actually, they are close to ours. I can make my own at home and I can afford it. The SLA part is protopolymerization. Protopolymerization is an application of laser light or UV light. It allows each of the values to solidify. Because of the laser nozzle or the flash UV light, this control unit is also complex. Then the photosensitive resin is used. So the price will also be higher. Basically, it is like a commercial shop. Or if there are some specific needs for model survey, the so-called SLA machine will be used. But with the rapid development of science and technology, now there are many household models. There is a Form 2 in a foreign country. It favors a high-level player. But the price is still a little higher than that of the average FDM level. Let's explain the FDM in more detail. In fact, we can see that there is a picture. It's in the process of squeezing. It's actually very simple. FDM, for example, PLA, or wires like ABS. Melt it one layer at a time, after melting with high temperature, and then pile up layer by layer. Of course, by stacking, the section line will be more obvious than SLA. But basically speaking, in the post-processing or now, there are some special solvents that can transfer these stacked lines, or the accumulated ones. Unfavorable texture. It can be soaked. What's just mentioned in the SLA? In fact, the laser light or UV light can be used to stack. The laser light was first applied. There are some special models behind the so-called UV light. If UV light is used, there is another method called DLP. That and SLA are very close. But there will be some differences in some parts of the digital conversion. The results are not so different. The SLA is less obvious in terms of the so-called gap. Basically speaking, there are some special requirements for mold turnover in the industry. If the cast wax is needed, a machine like SLA will be used. To mention a little more, 3D printing has some future development possibilities. Then I'll divide it into 5 aspects. Like the fashion industry or construction industry, health industry, food and environment industry. 3D printing has a great range for these 5 aspects. Let's talk about fashion. It is very early for the application of fashion in 3D printing. For example, there was a Dutch designer named Iris around 2013. He uses 3D printing to make something like garments. Well, there's something in the presentation just to show it. The appearance of the works, the whole piece, is made by 3D printing. Of course, there are some big limitations. Because most 3D printing products can't be very soft. Like cloth. Of course, with the development of some special materials, some artificial skin can be printed in 3D. But generally speaking, it is now applied in the garment industry. It is more likely that the hard materials will be made with the 3D printing. Besides the fashion industry, it has begun to have some applications in the construction industry. Because traditional buildings need reinforced concrete, it's hard to recycle. Because it is mixed with many different building materials, like tiles or steel bars. Now there is a startup company in the United States. They use 3D printing. They use concrete as the raw material, and then pile up layer by layer to build a house. And the advantage is that it can be used for a very long time. It can last up to 175 years without any damage, and again, because there is no need for manpower. It can work 24 hours without stopping. So the construction time is also very short. But of course, there are some restrictions because of the size of the machine. It can't print something too big. Of course, it's impossible to make a skyscraper, so the current technology application can only reach about 1 floor. But with technological innovation in the future, I believe there will be more breakthroughs like this. For example, maybe the whole building will be made by 3D printing. Besides the comparison just mentioned, in fact, there are more and more applications in health. As mentioned earlier, there will be some applications of 3D printing, such as artificial skin. Besides this, in the health industry, there is now the first artificial heart made by 3D printing. Of course, its strength is still worrying. But basically, the first artificial heart can beat at a frequency of about 30,000 times a second. Basically, this artificial heart is still in the research and development stage, so its durability is not comparable to that of a real heart, or compared with some old artificial hearts. But it is a great technological breakthrough, because it is a soft material that can be put in the position of a heart. In addition to the heart application, it is widely applied in prosthetics. Actually, there is a Victoria Hand project. It is dedicated to third world countries. 3D printing is applied to make customized artificial limbs. Actually, this activity has been initiated for many years. More and more countries benefit from it. Many humanitarian organizations have applied 3D printing. It will be more and more widely used in health. In the future, maybe many artificial organs can be made by 3D printing. 3D printing technology will replace other production methods. Then, this part is applied in the health field. There are also many applications of food. If you notice, actually, there are some TV news or TV programs. In fact, they all have some 3D printed introductions. Like the drawing machine with 3D printing recently. So, today's introduction is a 3D system. It has developed a special customized one. Use of a special customized machine. A machine for printing chocolate or sugar. Its name is Chef Jet. You can see that there are some shapes of sugar cubes and chocolate that are very special, and they are all made using 3D printing. Of course, it belongs to the customized food. Maybe in the future, when its speed or technology has increased, a lot of food or dessert decorations can use 3D printing. Finally, for the environmental aspect, we all know that global warming is very serious. The example I gave you today is actually in Australia. There is a plan to help coral reefs recover. Its coral reef is very special. They use 3D printing. The filled special limestone and ceramic coating in 3D printed materials is used to make artificial coral reefs. And the comprehensive pH value can be reached. Then, let it attach some algae and fish. So we can actually see that 3D printing is becoming more and more common, and the possibilities are growing. So this course is mainly to introduce this field to you. It is to let everyone know what the basis of 3D printing is. Maybe it can be applied in your professional fields. Maybe you are in different professional fields. Like the food mentioned before. Or if you're ambitious, maybe it can integrate self-control or experiential design. 3D printing will become very indispensable, even a potential for future development. End of this unit.